Hi everyone. Today we're going to study area of a sector of a circle. Let us define sector of a circle. A sector of the circle is that portion or part of the circular region enclosed by two radii and a corresponding arc. We have this figure. In this circle, we have two sectors. One is the major sector, the other one is the minor sector. But on this context, when we say sector, we are referring to this area. Now, the area of a sector of a circle. We have this figure and we have a central angle here given as theta. This is the formula. Given the central angle theta in degrees and the radius r, the area of sector equals theta over 360 times pi r squared. Now the length of an arc of a sector of central angle theta. With this figure, the length of an arc means we want to get the length of PQ. Now, given the central angle theta in degrees and the radius r, the length of an arc equals theta over 360 times 2 times pi times r. Example, find the area of the sector of a circle with radius 4 cm and of angle 30 degrees. Also, find the length of the arc of this sector. Use pi equals 3.14. We have this figure. We are looking for the sector. We write the area of sector. This is the formula. Then let us substitute the corresponding values. So we have 30 over 360 times 3.14 times 4 squared. We can simplify further. This fraction becomes 1 over 12 and this 4 squared is 16. Then we can use our calculator to get the final value as 4.19. Since this is an area, we write the unit of measurement as square of centimeter. Next, let us find the length of the arc, and this is the arc here. Let us substitute the values. So we have 30 over 360 times 2 times 3.14 times 4. We can get the final answer as 2.09. And the unit of measurement is centimeter. Hi everyone. Today we're going to study area of a segment of a circle. Let us define segment of a circle. A segment of the circle is that portion or part of the circular region enclosed by a chord and a corresponding arc. We have a circle and this is a chord. We have here two segments, namely the major segment, which is the bigger part, and the minor segment. But on the general context, when we say segment, we are referring to the minor segment. Let's have now the area of segment of a circle. We have this figure. Let us show the center with two radii, the radii that are connected to the endpoints of the chord. Then we show the central angle theta, which is given in degrees. We can see that the area of segment equals the area of sector minus the area of triangle. we know the formula for area of sector. That is theta over 360 times pi r squared minus the area of triangle, base times height, all over 2. Example, find the area of the segment AYB. If radius of the circle is 21 cm and the angle AOB equals 120 degrees. Use pi equals 22 over 7. This is our figure. So the area of the segment AYB equals area of sector OAYB minus the area of triangle OAB. And this is the corresponding formula. Let us first evaluate the area of sector OAYB with this formula. Let us substitute the corresponding values. So theta is 120 all over 360 times the pi is 22 over 7 times the radius, which is 21, which is squared. We can simplify further and this fraction becomes 1/3 and the square of 21 is 441. Using our calculator, the value here becomes 462. Then we go to the area of the triangle OAB with the formula base times height over 2. In the figure, this is the triangle here. Let us graph this down here. Let us draw a perpendicular bisector from the angle O to the side AB, and it touches at the point M. We can see that the 120 degrees becomes 60 degrees for each of the angles. We have two right triangles formed. In this triangle, we need the base and the height, which is not readily given. Let us solve for the height. Looking at this triangle, in one of the right triangle, we can see that the cosine 60 degrees equals the height over 21. Note that the height here is the line segment OM. We know the value of cosine 60 degrees and that is 1/2. When we cross multiply, we will get the value of h and that is the height. So it will be 21 over 2. Now let us solve for the base. In the figure, we can see that the base is the side AB. And this AB is twice the length of AM. We can solve for AM. Looking at the right triangle, the sine 60 degrees equals AM over 21. The sine 60 degrees is square root of 3 over 2. When we cross multiply, we will get the value of AM, and that is 21 square root of 3 over 2. For the base now, we're going to multiply 2 to the length of AM. And this is now the equation. We can see that we can cancel these 2 and the denominator 2. So the base is 21 square root of 3. So we have now the values for the base and the height. We can use this to solve for the area of the triangle. So it becomes 1/2 times the base is 21 square root of 3 and the height 21 over 2. The product of these three numbers is 441 square root of 3 over 4. Now we have the area of the sector and the triangle respectively. We can now use this to get the area of the segment. Substituting the corresponding values, we have now 462 minus 441 square root of 3 over 4. We can use our calculator and the area is approximately 271.04 square centimeter. This is the answer.